There's antimony, arsenic, aluminum, selenium, and hydrogen.
Today's lab is about reactivity of metals. We're going to do a little comparing of metals that appear on different parts of the periodic table. One type of metal that we're going to be analyzing today is referred to an alkaline earth metal. And if we break apart that name, we'll see that it's very appropriate. The term alkaline means basic. So the reason that alkaline is in the name of alkaline earth metals is that they form alkaline solutions or basic solutions when they react with water. So one of the tests that we're going to do today to see if we have a reaction between the metal and water is to add an indicator known as phenolphthalein. Phenolphthalein is an indicator that turns pink or fuchsia in the presence of a basic solution. The other metal that we're going to look at today and compare to is aluminum. Aluminum appears in group 13. So the three metals we will analyze will be magnesium, calcium, and aluminum. First metal that we're going to analyze is magnesium. Our magnesium is in the form of this flexible ribbon. So let's start out by recording some observations of this material. Now that we've recorded some observations of this material, let's test its reactivity with water. I'm going to take this piece of magnesium ribbon, put it into my beaker, and then add enough water to cover the surface. Now that we have the water and the magnesium in the beaker together, we're going to look for signs of a reaction. Things like release or absorption of energy in the form of light or heat. We will also look closely to see if we have the production of a gas. We could check for the presence of a new odor. So let's have a closer look at the magnesium in the water and see if we can notice any indicators of a chemical reaction. Now that we've observed the magnesium in the water looking for evidence of a chemical reaction, let's take it one step further by adding a couple drops of phenolphthalein. Again, the reason for doing this is to test for a basic or an alkaline solution. If we see a pink color forming in this solution, that tells us that there is a reaction happening. Remember, alkaline earth metals like magnesium will form a basic solution when they react with water. Our next metal that we are going to analyze is calcium. So let's take a moment to look at the calcium and record some observations about it. Now that we've looked at the calcium all on its own, let's test its reactivity with water. So I'm going to take a few of these calcium turnings, place them in my beaker, always a good idea to put caps or lids back on containers so they don't spill or get contaminated. Now let's add the water. Again, we're looking for evidence or signs of a chemical reaction. Also think about the rate of reaction for the calcium in comparison to the magnesium. Which one is reacting faster? Which one displays evidence that's more noticeable? Now, along with checking for the production of a gas here, which I think is pretty evident, another test that we could do is to fill the bottom of this beaker to see if any heat energy is released. And I will tell you, after touching the bottom of the beaker, that it is warm. So there is a release of energy that's also occurring here. Again, another indicator of a chemical reaction. Just like with the magnesium, we're going to now add some phenolphthalein to test for the presence of a basic solution, and that will indicate whether or not we have an alkaline earth metal reacting with water or not. See a very dark pink color there? Remember, that's an indicator that we have a basic solution, and therefore for us that indicates a chemical reaction. So that supports all the evidence that we've seen so far. Our next metal is aluminum. Now, this really isn't any different than the aluminum foil that you would buy in your ordinary average grocery store. So you're probably most familiar with this metal here. Let's take a closer look and record some observations. Now we're going to test the reactivity of the aluminum with water. But before we do, I want you to use a little bit of common sense. After a meal, you wrap up your leftovers with some aluminum foil. You go to the store, you're thirsty, you buy a can of Pepsi soda that's in an aluminum can. So think to yourself, how reactive would aluminum really be with water? Now that we've looked for evidence of a chemical reaction without the presence of phenolphthalein, let's add a drop and see if we see that characteristic pink color. We've looked at the reactivity of magnesium, calcium, and aluminum with water. In the second part of this lab, we're going to look at the reactivity of magnesium when placed in a flame. So really what we're doing is looking at the reactivity of magnesium with oxygen in the air. So let me light my burner. And adjust my flame. I'm going to use a pair of crucible tongs to hold on to my magnesium. Now, magnesium is going to release quite a bit of light, so much light such that when you observe this reaction in person, you want to observe it with your peripheral vision, so you don't want to look directly at it. The intensity of the light is actually strong enough to damage your vision. So I'm going to place the magnesium in the flame, Once it ignites, I'm going to hold it over top of the wire gauze. The magnesium, along with producing a lot of light, is going to produce quite an amount of heat energy. And if it falls on the countertop, it could damage it. So we're using the wire gauze just to protect the countertop. After burning, we're going to place what's left of the magnesium, and you can see it's changed its color here. We're going to place that into a beaker for some further testing. Now let's test the reactivity of the product formed from the magnesium reacting with the oxygen in the air. We're going to add some water. Now let's add the phenolphthalein. Let's look at how reactive the aluminum is when placed in a flame. You'll notice that the aluminum is glowing an orange color. That's just telling us that it absorbed some heat energy and then it's re-releasing it. When I remove it from the flame, we can see that the aluminum hasn't reacted away. So think about the intensity of the light and heat energy given off by the magnesium as compared to the aluminum. When we put the aluminum in the flame, it didn't produce much in the way of aluminum oxide. So instead of testing this, which is basically still aluminum, we're going to use some aluminum oxide, which would be the product if we provided enough heat and waited long enough for that reaction to progress. So let's take a spatula of this, put it in our beaker. We'll add some water. Then we'll add a drop of phenolphthalein to see if we have a basic solution. Today we collected some information about the physical and chemical properties of 3 metals. Those metals were magnesium, calcium, and aluminum. Some patterns to notice. The magnesium and the calcium, based upon the evidence, were more reactive than the aluminum. Take a moment to look at a periodic table. Think about the positions of the magnesium and the calcium versus the position of aluminum. Also think about the reactivity of magnesium in comparison to calcium within that same group. Do you see an increasing trend of reactivity as you go down a group, or do you see an increasing trend of reactivity as you go up a group?